Hello.
Hello, and welcome. Today, we're going to focus on designing Instagram. Here's the scope. We want to build a system where users can upload photos, view a feed of images, like posts, and follow other users. Let's start by defining the requirements. What do you think we need in terms of features and scale?
All right, so let's start off with the function requirements for Instagram. So the first one, again, we will need to upload photos. So this is a key aspect of the app, and it's one of the main things even to this day. And now let's do feed creation slash viewing as well. Does that sound right? Good?
Yes, that's correct and in scope. We've got uploading photos and feed creation viewing. Please add that to the whiteboard. Continue.
Okay, so now we also want to add user interactions. To be more specific, I'm just going to say following. That's also a key factor in the actual feed creation. So I think we can leave it at that. Does that sound good?
Yes, that's good. We now have uploading photos, feed creation and viewing, and user interactions like following. Let's lock these in as the core functional requirements. Next, let's think about non-functional requirements like scalability, performance, and reliability.
All right, so in terms of scale, what I'm assuming is we'll need around 500 million daily active users. We'll need some system to hold that. Does that sound about right?
Yes, aiming for around 500 million daily active users is a solid scale assumption for Instagram. That's a great baseline to start considering the infrastructure. Let's factor that in as we go deeper into the design. Please add that to the whiteboard.
All right, so now I think 10 posts a day would also be an accurate estimation of the actual people. Just posts could mean stories or actually posting on your profile, but I think that could be a good amount of data estimation for the user interaction in that case.
Understood. 10 posts a day per user is a reasonable estimation, covering both stories and profile posts. That gives us a good sense of the data volume we're dealing with. Let's lock that in as part of our scale assumptions. Please add that to the whiteboard.
All right. So now let's talk about availability. So consistency might not be the biggest thing in this case because you're going to have high profile celebrities such as Mark Zuckerberg, Elon Musk, the Kardashians. They're going to post, but the way that we give the profiles for them for the feeds is going to be drastically different than your average Joe. So even if we're not able to have the most consistent necessarily, if we're able to use that trade off to benefit availability, to make sure that whenever someone logs on to Instagram, they always have something ready for them, that could very heavily be important, and that is a use case in our scenario.
Absolutely. So we're prioritizing availability over strict consistency, ensuring that users always have content ready in their feed, even if it means eventual consistency for some posts. That's a key non-functional requirement. Please add that to the whiteboard.
All right. So now let's see. Now we have some functional and non-functional requirements. So I think now we've also got the scale done. So I think, yeah, let's focus on the high-level diagram a little bit, just introducing some stuff.
Good. You've set the foundation with the requirements and scale. Let's move into the high-level architecture. Start introducing the main components you think we'll need. Storage, services, anything you find essential. Then we'll dig deeper from there.
All right, so I'm just going to start off with an Instagram client, and I'll just add this text box, 500 million daily active users, just to have a note. So from here, there's a few things that we can do. So first of all, we're going to want to integrate load balancing of some kind. So this will be a global load balancer. because people from not only North America, Europe, and Asia, but every part of the world is interacting with Instagram. So we're going to need this global load balancer to be integrated. And then from there, I'm thinking there's a few main areas that we're going to have to deal with, and I'm just going to add a few services. Does that sound good?
Yes, that's a solid start. You've identified the Instagram client, noted the scale, and introduced a global load balancer. Now go ahead and add those key services you're thinking of, and we'll refine them as we proceed.
All right, so the first one I'm just going to add on to here as a black box for now. We'll just call it the feed generation service, and we'll get more into depth on it later. But we'll have that, and then what I'm thinking as well is we can have the actual uploading service. So after we add that, now let's also think feed generation uploading, and then let's just have a follower management system. All this basically does, it allows for, so actually let me explain this in a better way. If you're on Instagram, do you know when you see other people, such as people you may know, or there's a very intricate following network going on, correct?
Correct. The follower management system will handle that intricate following network, tracking who follows whom and providing the backbone for generating personalized feeds. Now that you've outlined the feed generation service, uploading service, and follower management system, you've got a solid high-level set of components. Let's keep going from here.
All right, so now I'm just gonna also, while we're talking about this, have some API endpoints just defined. So the feed generation, we're just gonna have a get to the slash feeds route, and then let's also pass in the user ID. And then our next one, the uploading service, we'll also have a post to slash uploads, and then we'll also pass in the user ID. And again, the body will contain body contains the posting, and it will have the image URL, etc. that's already been stored in the database, and we'll get to that as well. But there's that, and then let's also just have that follower management in some way. So we're just gonna have slash followers. All this will do will pass in the current users, followers, and the people surrounding them. And we're just going to have a brief layer of followers. We're not going to go too much in depth because if we do that, that'll just make some kind of recursion loop, and we don't really need to do that until the user actually clicks on the profile of the other person. So let's just stick with this. Connection disruption, but let's continue. So I'm thinking now we're going to have to add an API gateway between all these different APIs. So I'm just going to connect that real quick. And then now let's talk about queuing. So the queue, again, it just makes sure that all the people or all the requests are set up in an orderly manner so you don't overload the system at once. And that already is happening during load balancing, but a queue could be helpful for uploading and feed generation. Maybe not follower management if we're allocating the resources, but feed generation, we definitely want to make sure we're not overrunning that, and uploading also, same thing. So also I'm thinking we could do something like a Kafka queue, and from there we can have one directed to the feed generation and another generated towards the uploading service. So I'm just going to add that real quick.
Good. Adding a queue like Kafka for feed generation and uploading is a solid approach. That'll help handle spikes in traffic and ensure steady processing. Please go ahead and add that to the whiteboard. Then we'll dig deeper into how you plan to structure the queues and partitioning.
Okay, now let's get into some databases. So I'm just going to add two databases. We're going to have the user metadata database, and we're also going to have the post metadata DB. So now before we get into those, the storage of it actually, let's just break down some of the fields. So let me just break this down real quick. And now let's consider. So we'll start off with the user metadata schema.
All right, let's break down the user metadata schema. Think about key fields like user ID, username, profile picture URL, bio, and any follower or following counts if you want to denormalize that. Once you've outlined those key fields, we'll confirm if the structure meets the needs, and then move on to the post metadata schema. Go ahead and list out the fields you're thinking for the user metadata.
Okay, for the metadata itself, again, user ID, username, date created, and then let's just also have some more ideas such as the follower count, and we can go more into depth with the follower management. Let's just have that there for now. And for the post metadata, let's just consider a few more fields. So let me just add this to the whiteboard real quick. So post metadata db.
Understood. You've outlined some key fields for the user metadata. User ID, username, date created, and follower count. That's a strong start. Now for the post metadata, go ahead and list out the key fields you're thinking. Then we'll confirm everything fits together.
Okay, so I'm putting the post ID, image URLs, video URLs, the comments, the, the description. And these are just a few fields. Let's also have the like count. Let's have the like count, the share count, and let's see. Is there anything else I'm missing?
What you've got covers the essentials. Post ID, image and video URLs, comments, description, like count, and share count. Another useful field could be the user ID of the post creator, and possibly timestamps like creation time or last updated. That'll help with feed ordering. Once you add those, the schema should be pretty comprehensive. Then we can move into how you plan to store and scale these databases.
Okay, so the first thing I would do is shard both of the databases. Now, the user database, I would just shard off of user ID, and the post metadata database, probably the post ID or some sort. Now, we want to shard these databases because we're having to deal with 500 million daily active users plus, which is a lot of people to put into even a few databases. So we're going to have to horizontally scale this. Now, this just simply means having multiple instances, and I'm just going to add some backups real quick. We'll have a replica database of both of these just to have some backup if there were to be a massive failure in the servers for the database connection.
That's a solid approach. Sharding the user database by user ID and the post metadata database by post ID makes sense given the scale. And adding replicas for both databases ensures high availability and failover handling. With this setup, you've got a scalable and resilient storage layer. Now we can dive deeper into how you'll handle consistency between these replicas and any caching layers you might add on top.
All right, so the first thing I want to do is we want to have to add a cache between the uploading service and the feed generation service before accessing the post metadata database. So the first thing as well, we're going to have regional CDNs, which will cache highly regarded content, which means the uploading service will connect to the regional CDNs, which will then connect to, let me actually outline how we're going to save the posts themselves, so the images, videos, etc. So I'm thinking a database such as just S3 database or blob storage to store these for video and photos.
That makes sense. Using blob storage like S3 for storing the actual media, images, and videos is a great choice for scalability and durability. And placing a cache between the uploading service, feed generation, and post metadata database will help reduce latency. The regional CDNs for highly accessed content will ensure users get low latency delivery. Now that you've got your storage and caching layers outlined, we can explore how you'll handle cache invalidation and content propagation across these regions.
Okay, one thing, I'm probably going to rename this follower management service to just user management service, simply because the user and the actual application are going to have to connect a lot more. So I'm just going to have this, again, this will also handle following, as the user metadata database should include the follower counts, and I'll also add the followers directly. So we'll have that, just followers, the people who follow that user. And again, I'm thinking NoSQL for the post metadata and the um, again the replica, and then the user metadata itself, simply because we're gonna have so many, and it will be okay. So now I think we're almost done with this system. We've addressed the following: user management, feed creation and viewing, and then again user interactions. We're gonna have some heavy load balancing to handle that 500 million scale for daily active users, and again we're going to have shorted databases just to make sure that one database is not overloaded with information. So this will overall help our Instagram become scalable, reliable, and not have to go down pretty much at all with 99.99% uptime.
Yes, that's a solid summary. You've designed for scalability with sharded databases, load balancing across the board, and caching layers for performance. You've also accounted for availability with replicas and regional CDNs. The system is shaping up to handle that massive user scale with high reliability. If you feel comfortable with what's been laid out, we can dive deeper into any specific component or test any assumptions. Just let me know where you want to go next.
Honestly, I think this would be good for our interview today. We've discussed the trade offs as well with the, again, availability, the cap theorem, making sure that our consistency could have some leniency, but availability, we always need that to occur. Do you have any questions?
You've done a great job covering the key trade-offs, especially around availability and consistency. The system looks well thought out for the scale and requirements we defined. I don't have any further questions at this point. Well done.
Thank you. Have a good day.
You're welcome. You have a great day too.